Hey, welcome to today's webinar. Last time we were developing code for Smart Aquaculture, the Smart Aquaculture platform here for fishing trips. Fishing trips like if there's a dock that is collecting fish for seafood to sell seafood, and they go out on a fishing trip, what we want to be doing is tracking the date and time that they leave for that fishing trip, the date and time they come back to the port, and then the amount of fish they catch of specific species, and also the amount of bycatch, which is fish that sea creatures they caught that they weren't expecting to catch. Also, when the seafood goes to processing after that, we're trying to keep track of that in a blockchain kind of way, but we're still developing that. And we started on Friday, so now there's some questions about how that code generation was done with artificial intelligence. And that's what I want to explain more in this video. So we also didn't get to actually run this yet, so we're gonna fix the bugs and get it running. So let me show you here. We just created this Java class with some specific descriptions in the code. And the next step, what I need to do is make sure that I'm connected to my OpenShift local. So if I do oc get pod and it tells me you must be logged in, that means I'm not connected. So I log in to my OpenShift local with the admin credentials that it provides when you type crc start. These are the credentials here, and it's different for everybody. But this is always the URL to OpenShift local. So the reason we have to connect is because this Smart Aquaculture system connects to databases. It connects to Apache Solr search engine. It connects to Apache Zookeeper cluster manager, and a fireware context broker. And it also has all of the secrets for the whole platform defined as secrets in OpenShift. If I show you what I mean, um, I go to CRC OpenShift local here, and I log in as kubeadmin, and I go to workloads. There's Keycloak. I'm going to go to secrets, and I'm going to go to Smart Aquaculture. Anyway, so we have these secrets defined here. For example, authorization to Keycloak. These are defined as secrets. And then in our code, we're able to manage these secrets easily in this vars.yaml file. So if I search for secret, you're not actually going to find any password in this whole YAML file because it's set to at the when the program starts, it's set to query those secrets directly from your connected OpenShift cluster instead of exposing them in your own system environment variables or in your own files, which is insecure and prone to data leaks. We avoid that altogether by specifying the query to get those secrets in a specific namespace with a specific name and a specific key so that we keep the secrets out of the code, which is really nice. So because we do that, we have a search engine that knows everything about this fishing trip. So we wrote some methods that represent fields in this model, like primary key. We make it the unique identifier for this. We specified a departure date. We specified an arrival date, both as a zoned date time. And we specified a name as a string and a description as a string. Now, I think there's one. Oh, let's see. We still have a bug there that I need to fix in the code generation of the API. But let me just save that right now. Let me show you how the code generation works. So if I hover over this generated class, it didn't even exist, but we just typed in extends fishing trip gen and then these generic arguments for the base model. And what it does is it actually has a class generated under the hood. And let me show you the service that's running as well. So if I go to terminal, this is the logs. And if I think I showed this in my last video, but if I do systemctl -- user status watch smart aquaculture, then it shows me that there's a system service, user service that's active and running, and it's tracking the logs just like we do with journalctl. So if I go and touch this file, then it's actually going to go and revert that change that I made here. It's gonna say fishing trip touched, and it was, and then it comes here and rewrites the code. So it just turned blank, and then the code appeared, and then the error should appear once it's finished compiling this information. Got to be patient. But it generated this code. How does it generate all this code with all the imports and everything that it needs? So if I hover over this again, it's generated a bunch of comments for this class that kind of explain what was generated and what else you can do with this fishing trip model. But it has this link to find the class fishing trip in Solr. So I click on this, and it's going to, where it's going to is this Solr pod in here. So I do Solr as the project, and this is my Solr search engine pod that's running, and it has a route defined here. Solr app CRC testing. And that's where we are right here. And you put in an admin secret for Solr, and it shows you the data for this. So, so this is a query that I did. We can look at this a different way. I want to show you the actual Apache Solr interface. So I strip off all of this stuff at the end. Oh, let's just go to Solr appcrc.testing. We also put in our admin credentials, and then we go to the collection called Computate, and we go to query. And if I just run this query, this is saying that it knows 23,461 different chunks of code that I'm using on my computer. It knows 23,000 facts about my code. And nobody else knows this information. It's all stored on my own computer. So it's like sovereign. It's your own AI for code generation, which is my favorite part of this. But let's filter it down. So some of those filters that it applied in the previous query are here in the FQ section of the response header. It says part A class, which is because this is The Computate project is written in French. It's built to be international because it generates English code as a second language, which is kind of weird to think about, but that's how it works. So we're going to add a filter query here to say this is a class, true. So there are 294 Java classes known to my search engine. And then we add another filter that the canonical name for the class is this org.computate smart aquaculture model 5 fishing trip class. So we do this and we add another filter query. And now it found one result in the whole thing. And this is every single detail about this class. For example, it knows it's part of a project called Smart Aquaculture. It knows it has a superclass called base model. And it knows the complete canonical name and the simple canonical name. And it has code comments, and it knows the path to this class and whether there were APIs defined. So then what we do is we set up the whole API and we set up the URIs that we specified. It's all stored in here. And because we've recorded all this information, then we can go write code to build the API so that we don't have to write that code. It's just going to go and write 10,000 lines of code that we need to write, but we don't want to write ourselves. And if you take off this filter query, you're going to see all the other chunks of code that it knows about this fishing trip class. So we refresh this query and it says there's 6 different chunks of code that I know about, including, I call them part et entité. So what it knows is I come back here to, no, I come back to VS Code. All right, so this is the first thing it knows. It knows about this public class. It also knows about this method underscore PK. That's 2. It knows about departure date. That's 3. It knows about arrival date. That's 4. It knows about name. That's 5. And it knows about description. That's 6. So if I go and search here, you'll see, let's see, where is it? Oh, wait. Or actually, let me search for departure date because that's more unique. So I come here, I search for a departure date. So this is all the information it knows about this departure date class. It's a lot of information per method, but it gives us the context that we need. It knows that we want to store it in the search engine with doc values. It knows we want to store it in the database with this persists true. It knows the display name of this as arrival date there, and it knows the description of this, which is there, and where we want it to appear in the user interface, column 2, row 3, cell 1. You know that we want it to be a facet, so it's there. So there we go. We have all this information, and then this service is just going to go generate code for us. So it generated this fishing trip ENUS API service impl, and then what we want to do is make sure that our DB create script also knows about fishing. Oops, fishing. No. Oh yeah, that's what it's called, fishing trips. So this DB create script doesn't know about fishing trips. Neither does our Open API 3 spec. So if I search for fishing trip, doesn't know. but we can use the search engine information in here to automatically update these things. So here's what I do. I run this rebuild Smart Aquaculture API command, and let's see. So, but first, we actually need to resolve these bugs here. Oh, those are resolved. Let me do fix, update project configuration, and let's see. I think we're still going to have an error somewhere here. This one right here. So what I actually need to do is check in my Computate code where we build the APIs. I think I have a bug here for some reason. Set original. Um, so wherever we set the ID, what we really need to do is do this. Oops. We need to do optional dot of nullable map v to v dot toString. Dot or else null. And then let's see how this does after that. I think, wait a minute. That didn't look right. Nope, we did that wrong for some reason. Set original. Oh. No, 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 no. Sorry. Set ID. Set ID. All right, so I save that and then I come back here and I regenerate this fishing trip code and hopefully it'll resolve this issue. So we save it and then we need to wait a few seconds because it's not immediate. I actually have some plans to make this more efficient, but for now, we wait. But if it's going to write 10,000 lines of code for us, I think we can wait 10 seconds. It's okay. But let me do a Maven install because sometimes when you change the code in one VS Code, it doesn't know that it changed and it gets into this ugly state where it throws an error. So we're just gonna, it says it has some unresolved compilation problems. So we're gonna compile it again, and then we're gonna try again this fishing trip. So save. Okay, it did it this time. Fishing trip touched. I'm gonna wait for this to turn yellow and then check again. So I think it resolved that issue. Yay. So now we need to, oh, for some reason it does it twice. I don't know why, but anyway, it still works. Maybe we can get rid of that inefficient step if possible, but it still works. So we rebuild the Smart Aquaculture API and what it does is it queries the search engine And then it updates this db create script. So look, create table if not exists fishing trip. It's got the primary key, the created, the archive, the session ID, the user key, the object title, the display page, the departure date, the arrival date, the name, and the description field. And the Open API spec. If we search for this again, there's the fishing trip API for get and for patch, for post and delete, and import and get by primary key. So, and edit by primary key, search, fishing trips. It's got all these APIs and it just built them for us. So cool. So then we stop the application. We start it again. Also, we're going to use, we need to update the page layout here, page layout.htm. If we look for fishing, it doesn't exist. No results. So we're going to update the page layout. For that, we use the Computate Smart Website Builder. So I switch VS Codes to my courses, and there's this create scaffolding code, but it's also in regenerate base files. So this makes it a little easier. Also, I want to show you, it shouldn't, so it's also not in the main vertical. If you search for fishing, it's not in there. So what we do is we use this Computate Smart Website Builder to regenerate the classes like main vertical. I don't make this automatic because it's possible to customize the main vertical and there may be stuff that you don't want overridden. So I don't force you to do this, but what it does automatically for us is add the fishing trip into the right place in the authorized group data section for our specific groups that we defined here. We defined the authorization in this section for these groups like fishing trip viewer to get fishing trip editor, super admin, and admin. And so we regenerated the main vertical and it did, let's see where to go here. Did the authorization section. It also registered this as an auth resource in the search, an authorized resource, and then it initializes the whole API by its open API spec here in this register API service. So it wrote all that code for us. Nice. And then we'll also regenerate the worker vertical and the page layout. So now, if we look at the page layout, then we now have fishing trip here, a fishing trip. And if we start this application, clear, it's running. Now I just have to go to let's see, I forget. I need to make the log statement to show where it's running. Actually, I leave it up to users to figure out how to do that. But it should be at localhost 10230. And you see fishing trips here. So fishing trips, I'm going to log in as user one, sign in. No fishing trip found. Uh, okay, good. And then let me just check. Keycloak dot apps dash crc dot testing. No, wait, it should be temp admin. Let me see what groups. No. Smart Aquaculture users, user one, groups. Okay, I have admin, and let me check the permissions. Clients, Smart Aquaculture, authorization, resources, or permissions. Fishing trip. There's no fishing trip permissions. Resources, name, fishing trip. Okay. So let me see here. I thought this should run the authorization generator. Oh, it's because we update the main vertical with the authorization stuff, but we didn't run this rebuild smart aquaculture API after that. So it didn't actually do this authorize call, which actually creates the authorization information in Keycloak. So if I run this again this time, then it's going to come to this point. So it hits this breakpoint, and then we continue. And then if we look at Keycloak again, refresh, permissions, fishing trip, there they are. All the authorizations are applied. Plus, instead of just saying no fishing trip found, if we refresh, we should be able to create one now. There's the create button. Yay. So then create a new fishing trip. Description today. And create. And there it is. It was created. And here's the API for it with all the data. So we did that with generative AI with the Computate platform. And it leverages Apache Solr as the model for the code, for your code, and the service that's running here, and it just generates the code for you. And this is open source software. And so you can learn more with the Computate Smart website builder. But first, so if you want to do this yourself on your own computer, you go to computate.org and check out. First of all, we're going to be doing this next week at the Red Hat Summit in Boston, Massachusetts. So I recommend checking this out there if you're going to the Red Hat Summit. You're going to be able to vibe code this smart aquaculture data-driven website from scratch at the workshop. But you're going to be doing it in the cloud. So if you want to get started with doing this on your own computer, check out the Smart Cloud Deployer first. Here are the system requirements for that. You need to be running Linux, and this is the hardest part of the adoption is giving up your Mac OS computer or your Microsoft Windows operating system to run Linux. It's a big step, I know. It's very intimidating, but it gives you the power of open source once you're willing to move on and accept open source as part of your life and become an open source software developer like me. So, so the system requirements are there if you want to get started. And this is what I do. This is how I've developed all all the site build over the years, including these and many more, but these are the currently running ones. But we're also building one for Red Hat as well called AI telemetry, which you can learn more about that use case here for Red Hat OpenShift observability and the AI telemetry project. So anyway, that's more about code generation. So we're going to be doing a lot more of that. And thanks for watching.